All right, hello, welcome. Let's solve some more differential equations. In this video, I'm going to be talking about substitution again. And this is going to be, we're going to be interested in first order differential equations that can be written as y prime is some function of y over t. Now, this condition is, it's pretty much equivalent to what we would call a homogeneous differential equation. But I think at this point in the course, I don't really want to get bogged down into what makes a function homogeneous or what makes a differential equation homogeneous. I'm just going to say we're interested in ones that we are going to have like y over t and t over y, right? Because we can still say that t over y is a function of y over t. It's just y over t to the negative 1 power. So I think the first example I want to do, I just want to jump in and do some examples for you in this video. Yeah, I'm not sure if this one precisely fits the mold, but it does really give you a good picture of the technique. So, I guess it does. So this one is y prime equals, what was it? It was 2y over t plus the secant of y over t squared. And this is the type of thing that, we don't have a technique to deal with this right now. Okay? But much like in the previous video, I'm going to make a substitution. I'm going to choose some function of y and t for v to be. And then I'll need to figure out what y prime is in terms of v and t, and I'll make the substitution. And all of a sudden, again, I will see that it's a separable differential equation. That's the deal with first order differential equations that you're going to solve with substitution. The substitution method, it turns it into a separable differential equation, which is something we're very good at, right? So what I want to do is I want to start with, my choice of v. So in this situation, I think I'm going to let v equal y over t squared, just because I know I want it to. So I'm going to say let v be y over t squared. Okay. Well, I think right off the bat, I need to figure out what is y over t. Okay, y over t is like, wait, is that what I want? Is that going to be vt? Yeah, because if I multiply, so just, kind of as an aside, I'm going to say that y over t is equal to v times t, because that's something I'm going to need to deal with in a minute. Okay, but if v is y over t squared, then y will be equal to vt squared. Okay. And then I will have, really what I have is y of t is equal to v of t times t squared, right? For the same reasons as in the last video. So I've got y of t is v of t multiplied by t squared. So when I take the derivative of y with respect to t to get an expression for y prime to substitute there, I'm going to need to use the product rule. So y prime is going to be equal to, take the derivative of v, leave t squared the same, plus leave v the same and take the derivative of t squared. So that would be 2t times v. Okay? And now I've got all the pieces ready for substituting, right? I'm going to take this and I'm going to put it in there, and then I'm going to put v inside of the secant, and I will express that as 2vt. Okay? So y prime is equal to v prime t squared. Maybe I'll call it t squared v prime. Plus 2tv. Okay? And that's equal to 2 times y over t. Well, y over t I said was vt, so that's going to be 2vt plus the secant of v. And what do you know, 2vt and 2tv and 2vt, they're the same thing, right? So I could just subtract them from both sides of this equation. And I could be left with something like v prime is equal to secant of v over t squared. Okay. Now, this is separable, right? I can go over here and I can say, well, what I'm going to do is I'm going to move the secant, I'm going to divide both sides by secant of v, which will give me a cosine of v on the left. So I'll have cosine of v dv equaling, what is it, t to the negative 2 dt. All right, we can deal with this. We know an antiderivative for cosine of v with respect to v, that's going to be sine of v. And an antiderivative for t to the negative 2, I'm going to increase the power by 1, divide by the new power. That'll be negative t to the negative 1 plus c. Okay. Now, just like last time, I'm going to start trying to get at v, because if I can get at v, then I can get at y. Okay. So v is going to be equal to inverse sine of negative 1 over t plus c. Right? And then v is equal to y over t squared. And that's equal to inverse sine of negative 1 over t plus c. And then it's pretty much all over. I've got my y of t, got a general solution. And that's going to be t squared times the sine of negative 1 over t plus c. Okay? This is kind of the substitution technique for when you're seeing lots of y over t and t over y and stuff. I think I'm just going to do one more example in this video and then kind of just, set you loose on others that fit this pattern. And then I think at this point, this will probably be the last of our techniques to deal with first order differential equations. And then we'll move on and do some second order differential equations. Okay. So yeah, let me get you another example. All right, here's another one. And this one is, also not written as y prime as a function of y over t, or it doesn't quite look like it. But, the first step is going to be to divide everything by 2ty, and then you'll see that it will work out being, we'll have y's and t's divided by each other. So, if I tried to isolate y prime, I'm going to divide by 2, divide by t, and divide by y. So, I'll have t squared over 2ty. Maybe I'll just write that. Plus 2y squared over 2ty. Okay, well, what's going to happen here is kind of the same thing on both. I'm going to end up with y prime equaling, all right, kill off one power, and I'll have t over 2y. I might call that 1/2 of t over y. I'm not sure. I struggle to remember where this example goes. I just have it written down as one of the cases where this works. Plus 2 divided by 2, y squared divided by y, that's going to be 2, or just 1 y over t. Okay. On this one, I'm going to want to choose v equals y over t. If you choose v equals t over y, you'll see that you have to deal with the quotient rule, and it's just worse on the substitution. You could. I think it would end up giving you kind of the same thing, but who really wants to go down that road? I know I certainly don't. So I'm going to, use my substitution. Get this colored piece of chalk. I'm going to say let v equal y over t. Okay. Then y is equal to v times t. And y prime, v of t times t is going to be, I'm going to have to use the product rule. So I'm going to take the derivative of v and leave t the same. And then I'm going to leave v the same and take the derivative of t with respect to t, which is just going to be 1. Okay. So I've got, my terms ready to substitute on. So I'll have y prime equaling, wait, I've already got y prime. I need to substitute on y prime, right? All right, so y prime is v prime t plus v is going to be equal to 1/2 t over y. So this is t over y is v to the negative 1. So this is 1 over 2v plus, well, a v. And what do you know? I've got these two here, they can subtract away. Subtract v from both sides, and all of a sudden I have a separable differential equation. Okay, so I'll have v prime t equals 1 over 2v. Okay, and so really it's going to be, I'm going to multiply the 2v over here equals 1 over t dt. Okay. And then from here is separable differential equations. This is what we're good at. I'm going to take it all the rest of the way and get myself a general solution. But I think you could probably take it here also. So antiderivative for 2v with respect to v is going to be v squared. That's going to be log of t plus c. Okay. And then I suppose I could take the square root of both sides. And, you know, depending on the initial condition, it'll either be the plus or the minus, but not both. Okay? So maybe I'll give this one an initial condition and find myself a particular solution just to remind you of how that worked. Suppose we have, oh, wait a second. I have not taken this all the way. I've got v in terms of t, but v is not y, right? V is equal to y over t. So I'll go here. So then y of t is going to be plus or minus t square root of natural log absolute value of t plus c. Okay, that plus or minus t in there I think is going to be interesting. All right, so think about my initial condition. I definitely want my initial t to be 1, so I can take the log of 1. Let's just say that t is 1 and y is negative 1. So if y of 1 equals negative 1, then we have y of t equaling, let me see if I can figure it out. All right, if t is 1, I'll have 1 times the square root of 0 plus c equaling negative 1. So I need to use the negative. And then that needed to be plus 1. Okay, I'm not going to think too hard about like what the actual domain of validity of this solution is. I don't know, that's something you might could explore on your own. Or use technology to explore also. That's probably what you should do if you are interested. But you know, this is the substitution technique. This is a couple of videos that I certainly didn't anticipate putting on this playlist because I was just kind of unaware of this technique, honestly. But you know, the stated goal of this video series is to prepare you for the solving aspect of the differential equations course, so that when you get in there and you're taking it for credit, you're able to focus on the meaning and the application problems and all that stuff, and you don't have to worry so much about the algebra and the different techniques and stuff because maybe you've already worked them. Okay, so in the next video I'll probably be launching off into discussion of second order ODEs.